In order to search the best fit hypothesis, there are two algorithms are is recommended. One is the Findus algorithm. So Findus algorithm is finding a maximally specific hypothesis. So the algorithm states we have to initialize H to the most specific hypothesis. That means all 5 values. For each positive training instance X, we have to take up the given training examples one by one. For each attribute constraint, for every attribute in that example X, we have to take the constraint, the value, and if the constraint is satisfied by X, then do nothing. Suppose in our most specific hypothesis, the values of the instance is satisfying, we need not to do anything. Otherwise, replace the most specific hypothesis value with the value available in the instance. That is what the algorithm says. So this step is repeated for all examples given. Then finally, the hypothesis, what is generalized, will be the one which is output. So we have here, we begin with the most specific hypothesis, then generalizing it to the more general form. That is what. So illustration here, take our own example, Enjoy Sport, with a given 4 examples, and along with attribute values for every example and corresponding labels. Now, the step 1 to initialize H0. There is a first hypothesis, initial hypothesis. As per the algorithm, it should be a most specific one so that H0 takes all 5 values. Now, the first instance X1 is taken. The example X1 is taken. This is X1, X2, X3, and X4. X1 having value sunny for the first attribute. So this is sunny. And warm for second attribute, normal for third, strong for fourth, and warm for fifth, and same for sixth example. So on observing the first training example, this is a positive example. That's why we are considering. Here we have to see, in order to determine whether it is positive or negative, the Enjoy Sport, this label has to be looked at. That is yes, so it is a positive example. Right? Now, what's the task, search task here? We have to match this hypothesis value with the example value. If it is same, we have to do nothing. It is different, we have to replace everything by the specific value. So here all here are not matching. So we have to change the every 5 with the specific values taken in the X1. So that your next hypothesis H1, next level of hypothesis H1 will become all the like this. The 5 is replaced by these values correspondingly. Now, the second example X2 is taken. X2 is also a positive example. So this is what X2. Okay, this is actually a positive example. We have to now compare the previous example, previous hypothesis values. This is what previous hypothesis value with the X2. Wherever there is a mismatch in the previous hypothesis H0, here is sunny, here also so the X2 also sunny, need not to replace. In the H0, sorry, H1, there is here in this place there is warm, here also warm, X2 also warm, so keep it. But in H1, the third value is normal, but here the third value is high, so replace it with question mark. Similarly, the fourth value is similar, no change. Warm, the fifth value is similar, no change. Sixth value is also similar, no change. Now, this is how the mapping and replacement happens. Now, the third example is a negative example, so we have to ignore it. So that there is no change in the hypothesis 3. As it is similar with the H2. And next is the fourth example, which is having values sunny, warm, high, strong, cool, and change. You look at here, these values are matched 1 to 1. Here is sunny, here is also sunny. In X3, H3, there is sunny. First value is sunny. X4 also, so keep it. Here, second value is warm. Here also warm, keep it. And here you see, this is question mark, right? But what is here in X4? There is a specific value high. So we need to replace. Sorry. Right. Yeah, where here this is high, this is question mark, right? There is a difference. Here, this cannot be, because this is more general value, there is nothing to be replaced, so keep question mark. And the fourth value, both are strong, keep it. The fifth value here is warm and here is cool. So there is a difference, replace with the question mark. Here also the sixth value, same, change. These are mismatching. So keep it with replace with the question mark. So all the examples X1, X2, X3, X4 are considered. Finally, the hypothesis H4 is arrived, which is the final one. Okay. Now this summarized, the task is summarized. Step 1, we are initializing H with more specific values. Step 2, according to the first training example, we are constructing H1. Since there is a difference, we are substituting with the you are moving towards generalization. So instead of than phi sunny, the specific value is greater. The third step, considering the second sample, so our hypothesis become like this. The fourth step, considering the third example, but it is negative, we leave it. And then finally, after considering the fourth example, your hypothesis takes the form sunny, warm, question mark, strong, question mark, question mark. Okay. This is how actually finders algorithm works. Let's understand the problems with finders. The problems, yes, that is pros and cons of finders. Problem is, it's throwaway information. That means the negative examples are not considered. So it is leaving some information. And we cannot tell whether it has learned the concept, right? Because there may be several hypotheses that fit to hypothesis, the target concept, but we are picking the maximally specific hypothesis. So that's why we cannot say the one what we find is the most fit. The training data also, we cannot tell when it is consistent, when it is inconsistent, because we are ignoring negative training examples. But the algorithm is so simple, it overcomes the independent order of examples. And now let's look at, to overcome the problems listed here, what alternative method is available. So what we have to do is keep all consistent hypotheses. Don't throw away anything. Don't ignore anything like. So the one algorithm which helps us to overcome the problem is candidate elimination algorithm, which we are going to discuss in the next session. Thank you. Thank you for listening.